1,000 years ago, Viking farmers in Norway stacked layers of living earth on their rooftops. Grass, roots, and soil were packed over birch bark. Those roofs matched the insulation performance of modern fiberglass. They cooled homes in summer. They held heat through brutal Arctic winters, and they lasted centuries. No factory materials, no energy bills, no maintenance contracts. Then the modern construction industry replaced them with products that fail after 15 years. This video reveals what was lost and how to bring it back. Welcome back to Construction Odyssey. If these buried building techniques matter to you, subscribe and hit the bell so you never miss what the roofing industry hopes stays forgotten. Picture the western coast of Norway around 900 AD. Wooden longhouses dotting valleys between fjords. Snow falling 5 months of the year. Winter temperatures plunging well below zero. Summer sun barely setting for weeks. A climate that punishes any building not designed to handle violent extremes. The families who survived here looked at what the land gave them and engineered a roofing system so effective that modern scientists still struggle to improve on it. They started with heavy rafters of pine or spruce laid at a steep pitch to handle snow loads that would collapse a modern truss system. Over the rafters, they laid tight rows of split planking. Then came the critical layer, birch bark, sheets harvested in spring when the sap made it peel in wide, flexible strips. They layered the bark 6 to 8 sheets thick with the outer waxy surface facing up. Birch bark contains betulin, a natural compound that repels water and resists rot for decades. This was a precision waterproofing membrane that outperformed many modern synthetic products in longevity and breathability. Builders selected bark only from mature trees, rejecting pieces with knots or damage. Each sheet overlapped the next like shingles, directing water downslope in channels that never allowed pooling. The craftsmanship was deliberate, methodical, and built on generations of accumulated knowledge passed from parent to child. On top of the birch bark, they stacked 2 layers of sod. The first laid grass side down. The second laid grass side up. Total thickness ranged from 8 to 12 inches of living earth. Roots, soil, microorganisms, grasses, wildflowers, and moss. All of it alive. All of it working together as a single thermal system. Researchers at the Norwegian University of Science and Technology in Trondheim measured surviving historical sod roofs and documented thermal resistance values between R20 and R40. The International Residential Code in the United States requires attic insulation of R30 to R49, depending on climate zone. Viking farmers achieved comparable insulation, using nothing but earth and grass a full millennium before fiberglass was patented in 1938 by Russell Games Slater at Owens Corning in Toledo, Ohio. But insulation was only part of what the sod roof accomplished. In summer, the grass and soil absorbed solar radiation and released moisture through evapotranspiration. Water drawn up through the root system evaporated from leaf surfaces and carried heat away from the roof. Researchers at the National Research Council of Canada measured heat flow through green roof assemblies during summer and documented reductions of 70 to 90% compared to conventional roofs on the same building. This cooling by evapotranspiration kept interiors far more comfortable without mechanical air conditioning. In winter, 12 inches of dense soil and root structure created massive thermal mass. Heat from inside the dwelling migrated slowly into the earth layer and was held there. Snow accumulated on top and added another insulating blanket. The dense living layer buffered temperature swings that lightweight modern insulation handles poorly. A fiberglass bat responds almost immediately to exterior temperature changes. A sod roof absorbs those changes, holds them, and releases them hours later. The acoustic performance was another benefit that modern roofing cannot match. The dense earth layer absorbed sound from rain, hail, wind, and wildlife above. Inside a sod-roofed home, a violent storm registered as a dull murmur. Compare that to a modern metal roof amplifying every raindrop into a drumbeat, or asphalt shingles transmitting wind noise directly into the attic cavity below. Stormwater management added yet another layer of performance that conventional roofs ignore entirely. When rain hit a sod roof, the soil and root matrix absorbed and retained up to 80% of the rainfall. Water that did eventually drain off moved slowly and filtered through biological material before leaving the roof edge. A conventional shingle or metal roof sheds 100% of rainfall immediately, sending it surging into gutters, downspouts, and storm drains that overwhelm municipal systems during heavy events. Modern cities spend billions building stormwater infrastructure to handle runoff that living roofs would have absorbed for free. A single sod roof on a single home retains thousands of gallons of rainwater per year. Scale that across a neighborhood, and the flood risk drops measurably without a single pipe being laid underground. The biodiversity benefits were equally significant. A living sod roof was not just a building component, it was a functioning ecosystem. Bees, butterflies, beetles, and birds used rooftop meadows as habitat corridors across landscapes fragmented by human settlement. Native wildflowers on Viking rooftops supported pollinators that in turn supported the crops growing in fields below. The roof fed the farm fed the family. The system was circular in a way that no petroleum-based shingle has ever or will ever replicate. The longevity defied everything the modern roofing industry sells today. A standard asphalt shingle roof lasts 15 to 25 years before full replacement. Cost runs $8,000 to $15,000. Every 15 to 25 years, families write those checks again. 20 million tons of asphalt roofing waste enters American landfills every single year. Sod roofs in Scandinavia lasted 50 to 100 years with minimal maintenance. The turf-roofed buildings at the Norse Museum in Oslo include structures with original sod assemblies dating back hundreds of years. That durability, combined with free heating, cooling, stormwater management, sound damping, and habitat, explains why these roofs were once so widespread. On the Faroe Islands, turf-roofed homes from the medieval period still stand in Kirkjubor. In Iceland, the turf houses at Glaumber maintained habitable conditions through some of the harshest winters on Earth, for generations. These were sophisticated thermal envelopes, built by people who understood that a living roof repairs itself. Grass regrows, roots spread, soil organisms rebuild structure. The roof heals damage that would require a contractor and a 5-figure invoice on any modern home. So why did the most durable, most thermally effective roof system in human history disappear? The answer sits in the economics of an industry that profits from failure. The global roofing market generates over $156 billion a year. That market depends on roofs that deteriorate. A roof that lasts a century and repairs itself generates 1 sale. A roof that fails in 20 years generates 3 to 4 sales over the same period. Picture executives in boardrooms reviewing product lifespan data not as a problem to solve, but as a revenue model to protect. The asphalt shingle industry alone generates roughly $12 billion a year in the United States. Products are engineered for planned obsolescence, dressed up as affordability. A price from $5,000 to $8,000 up front looks low. Stretched across 60 years with 3 replacements, the total reaches between $20,000 and $45,000. Add the landfill waste. Add the petroleum products in every shingle. Add the heat absorption of dark asphalt that drives up cooling costs by 15 to 25%. The cheap roof is the most expensive thing on the house. Building codes reinforce the status quo. Modern codes specify roofing materials by product classification, and a living sod assembly does not fit any existing category. An inspector reviewing turf roof plans has no testing standard to reference, no fire rating to check, and no manufacturer warranty to file. It is not because the system fails. It is because the forms were written for products the industry sells. Insurance companies evaluated risk based on databases populated entirely by conventional products. Underwriters stared at green roof proposals the same way mortgage lenders stared at unconventional systems for decades. The spreadsheet had no row for a living roof that outperforms everything in the catalog. The safest roof in history was priced as the riskiest, because no one in the office had seen one before. But the science kept building until it became impossible to ignore. In 2003, researcher Karen Liu at the National Research Council of Canada published thermal performance data from field-tested green roofs. They recorded summer heat flow reductions of 70 to 90%. They found measurable insulation benefits in winter, and a dramatic extension of membrane lifespan. In 2005, researchers at the University of Toronto demonstrated that green roofs reduce cooling energy demand by up to 75%. At Lawrence Berkeley National Laboratory, Hashem Akbari documented how conventional dark roofs raise city temperatures by 2 to 8 degrees Fahrenheit. Green roofs reverse this effect. Every sod roof installed lowers the temperature of the air around it. In Germany, the modern green roof movement took hold decades before any other nation paid attention. By 2020, Germany had installed over 86 million square meters of living rooftop. Cities including Stuttgart, Hamburg, and Munich passed ordinances requiring green roofs on new construction. German insurance companies adjusted premiums downward for buildings with green roofs, based on reduced stormwater runoff and longer structural life. In 2009, Toronto became the first North American city to mandate green roofs on new buildings above a certain size. Copenhagen followed with aggressive requirements tied to carbon neutrality goals. France passed legislation in 2015 requiring new commercial buildings to install green roofs or solar panels. Singapore developed ambitious programs with over 100 hectares of rooftop greenery planned. In 2023, the United Kingdom Building Research Establishment formally recommended green roof and thermal mass strategies as key components of climate adaptation for new construction. So what can you do right now? On your own roof, with your own hands. Modular green roof systems have made the sod roof accessible to anyone with a flat or low slope roof. Pre-planted sedum trays sit directly on a waterproof membrane. You lay a root barrier, a drainage mat, and snap the trays into place. Costs range from $10 to $25 per square foot installed. A 200 square foot section costs $2,000 to $5,000. That can cut cooling loads by up to 75%. Membrane lifespan can be extended by 200 to 300%. Toronto, Copenhagen, San Francisco, and Portland, Oregon currently offer rebates and tax incentives. For pitched roofs, a combination approach captures much of the benefit at lower cost. One bucket of elastomeric white roof coating costs $50 to $100. Applied over dark shingles or metal, it reduces surface temperature by 50 to 60 degrees Fahrenheit. Lawrence Berkeley data confirms cooling bill reductions of 20 to 40%. One afternoon with a roller. Add a radiant barrier in the attic. Reflective foil stapled to roof rafters costs 15 to 25 cents per square foot. It reduces summer attic temperatures by 20 to 30 degrees. Combine the reflective coating, the radiant barrier, and improved ventilation. You replicate core passive principles for under $1,000. A family making these changes eliminates 30 to 50% of their heating and cooling expense permanently. Viking builders in 900 AD solved a problem that the modern construction industry pretends requires expensive equipment and monthly energy payments. They put living earth on their roofs. The earth insulated their homes. It cooled them in summer. It buffered temperature swings. It repaired itself. It lasted generations. It cost nothing but labor. Every principle they used has been confirmed by the Norwegian University of Science and Technology, the National Research Council of Canada, the University of Toronto, Lawrence Berkeley National Laboratory, and the UK Building Research Establishment. More than 86 million square meters of modern green roofing cover German buildings. Toronto mandates it by law. Copenhagen, France, and Singapore are following. The data is not disputed. It is simply not discussed where families make building decisions. Because a roof that insulates itself, cools itself, repairs itself, and lasts a century cannot generate the recurring revenue that a 15-year shingle generates. Every conventional roof you have ever lived under was designed to need replacement. That was never a flaw. It was always the business model. Viking farmers knew 1,000 years ago that the earth beneath their feet was the finest roofing material ever created. The modern industry spent a century convincing you to buy something worse. But the soil has not changed. The grass still grows. The physics still works. If this opens something for you, subscribe to Construction Odyssey and hit the bell. The next episode opens soon.